All right, ladies and gentlemen, this is the beginning of our chemistry unit. All right, this is actually my favorite unit because this is what I got my degree in college. So I do have a bit of knowledge about chemistry, and this is going to be a long unit. There's a lot of things that we're going to be covering as we go through. But the first thing that we're going to be talking about is what's called matter and how to be able to describe matter. All right, so what is matter? Okay, basically matter is made up, or everything is made up of matter, and we'll learn later on that everything is made up of what's called atoms and molecules. Right? You probably have heard maybe these words. You might not understand what they actually mean yet, but we'll get into the structure of matter a little bit later. But first thing is anything that takes up space or anything that has mass is considered matter. All right. And what chemistry is all about, it's all about observing matter, right? And how does it interact with one another, right? How does it interact with other matter? That's what chemistry is all about. And we'll learn later on about how that works and how electrons play a role in this. But the idea is you're using a lot of observations to figure out what just happened, all right? So the first thing we have to do is we have to be able to observe certain characteristics of matter, all right? As a chemist, you have to be able to look at matter and be able to identify certain things about it. That's going to help us describe or explain, hey, if I mix this with this, what's going to happen in the future? All right? So a lot of you guys think, oh, I can just mix this and mix this. What happens? That's the question I always get. And a lot of times it's nothing. Nothing really happens. All right? But on certain times, when we put two things together, matter together, yeah, there can be some violent reactions that might take place. But the first thing that we're going to do is we're going to be describing matter this week. And the way we describe matter is in two different ways. We can describe matter physically, and we can describe matter chemically. And what these two things do is it helps us identify, right? It helps us identify matter. Why is this not writing very well? Oh, well, right? So that's the whole point of being able to do that, all right? And a lot of times we talk about doing this with our senses, but you're just describing what that object is. We do this every single day, all right? When you see your friends wearing a new shirt or something like that, you know, you describe, or if you bought something, you're trying to describe it to somebody, you describe it the way it looks. That's kind of what we're going to be doing this week. All right, so moving forward, physical properties. All right, so when we can identify an object, the way we describe matter physically is we describe matter that can be observed or measured. All right, and examples of these things is what color is it? How does it feel? What kind of texture is it? Is it bumpy? Hardness, is it soft? Is it flexible? All right, what does it smell like? What is the state of matter? All right, is it a solid? Is it a liquid? Or is it a gas? All right, what's its boiling point and melting point? All right, these are all things that I'm going over. I'm not going to go over all of these. Now, these are just some of the physical properties. There's a bunch more that I'm not going to list because I don't have the room to do that. But these are all things that I can use my senses to describe it, or I can go out and measure these things, right? Like density, right? We always, we know that we can use the equation D equals M over V, right? To find the density of a property, right? So like these are all just some of the things that helps us explain what that item is what that item is, all right? And this is on a physical level, all right? We'll talk a little bit in a minute about the chemical properties, right? So as an example of how I would write these things down. All right, so let's say I had ice, and you were trying to describe what ice looked like to someone who's never seen ice. All right, maybe to a blind person. All right, these are maybe some of the words that you might use. You might use it's transparent. All right, you can see through it. It's smooth. All right, it's very, very hard. It's not very flexible. So in other words, I can't bend it. It's very, very cold to the touch. You really can't smell it. It's a solid. It melts at 0 degrees. Ice boils at 100 degrees Celsius, and its density is a little bit less than 1, right? 0.997. You can even also say that it, right, floats in water. That's something that we can use to describe it. So basically, you're using all of your senses to kind of explain what it is. And hopefully, if you explain this to a blind person, they would kind of be able to visualize, okay, what does ice really look like? What does it feel like as you're going through? All right. So now let's go to chemical properties. All right, this one's a little bit tougher because a lot of you guys have never really dealt with chemicals or described things chemically. All right, you've always described things. Like if you say, hey, I bought this new shirt and it's green, it's this. How many times do you say, oh yeah, my shirt's flammable, right? You never really say that, but that's another way to describe your shirt, all right? That it's flammable or that it rusts. You don't really describe things that way, but this is one of the things that as chemists we do. We use more chemical properties than a lot of other things. All right, but the idea of chemical property is it describes a chemical, right, based on its ability to change into something else. Okay? In other words, what does it react with? So what I'm looking for is what's called reactivity. That's what chemical properties are. It's how does it react with other matter. All right? So again, what I described was, is it flammable? Right? Does it rust? Rusting is when a penny rusts, it actually turns into a different chemical. All right? Does it spoil? Right? Your milk. All right? I mean, how many times if I said, "Hey, describe milk to me," how many of you guys would say? And some of you guys might say, after a long period of time, it begins to spoil, it becomes rotten, and it starts smelling bad. But most people would say it's white, it's a liquid, you can drink it. Right? Other things, and these are things that we're going to be talking about later on, right? You might have not had really to deal with these things, but how does it react with an acid? All right? That tells us a lot. What is its pH? Is it an acid or a base? And on the next few slides, I'll talk a little bit more about that. And then how does it react with iodine? All right? All of these things, if I were to do some tests, and in the labs that you're going to be doing this week, you're going to be doing some of this to identify certain chemicals or certain matter. All right, so let's go a little bit more into acid and base because it's a really good kind of a chemical property to do, and it's really simple. But pH is basically it's a measure, and some of you guys who might have pools know a little bit about pHs and stuff at your house. But what pH does is it measures how acidic or basic it is, and it basically, it's the understanding is it describes its reaction with water. All right. Most every object has a reaction with water. The thing is you don't see the reaction really taking place all that much unless it's something very like sodium or something like that we'll get into. But the idea is the scale goes from 0 to 14, right? And if you look at this part right here, so 7, this is what we call neutral, right? And everything up this way is an acid. And the higher up you go this way, this is the stronger it gets, right? And then the same thing over here. This way, it's a base. And the closer you get to 14, the stronger that base becomes, all right? So this is what we call over here, anything a little bit above 7 would be a very weak base, and anything below 7 would be considered a weak acid. But as you get closer to 0, it becomes stronger and stronger. Okay? All right. A little bit more about acids. Basically, acids are most of the things that you eat are acids, right? And bases, a lot of your cleaning supplies are your bases, right? Part of the reason why most of your food that you eat are acids is because your stomach is acidic. So it can handle acids a little bit more than it can bases. Now, does that mean you never eat anything that's a base? No, not necessarily. All right? But the idea is it feels like bases feel slippery. They're bitter tasting. All right? Acids are a little sour, like lemons, vinegar, and things of that nature. Okay? So that's kind of an idea. And we'll do a lab going over acids and bases. All right, so an example of how we would use chemical properties to describe something, just like I did with ice. All right, so if I want, again, if I were to explain sodium to someone who's blind or who's never ever seen sodium before, how would I describe it chemically? Now, this is a little bit tougher to do, all right, because you might not know what it reacts with. But sodium reacts very, very violently with water, all right? It's non-flammable. It reacts with an acid, right? It reacts with hydrogen, right? And when I say reacts with an acid, it actually bubbles up. It's a base. It's a very, very strong base. So when you pour sodium into water, because it reacts violently with water, it's a very, very strong base, all right? And then it reacts with iodine. So this is how I would describe it. Now, here's the thing. If I'm probably describing sodium to somebody who's never seen it before, they probably, if I say all these chemical properties, most people are not going to be like, oh, I know what sodium is. You usually use physical properties to help someone understand what it looks visually, right? But chemically, what does it really, really do? What does sodium do? This is what you would describe it through chemical properties. All right, now it's your turn. Here's an apple. What I want you to do is I want you to identify as many physical and chemical properties of an apple. So like what I want you to be able to do is I want you to at least describe 5 physically. All right, and I know chemically it's a little bit tougher, so I'm going to say 3 chemical properties. All right, as you're going through, and this is, once you do that, that is the end of these notes. Okay, all right.